So today we will be presenting our application BEAM. We are MKS Tech. We are architects that turn into, let's say, programmers in the past years. And this is about the workflow from Rhino to BEAM platforms, Revit and also IFC. We build applications for architects by architects, so we try to make everything easy and to work under deadlines. And today we're gonna show the main features of this app, and so we can you can see how maybe this can be a tool that can help you to streamline this workflow and make it easier. The idea is that we beamified Rhino, so you can attach metadata to the objects and prepare them for several workflows, export them to different platforms, or even maintain the Rhino file itself as a BEAM file where you can extract data and have a bit more of information attached to the geometry, and also to make proper BEAM objects. So today so there is a free version of BEAM, but for this workshop we are giving you a license so you can remove all the limits of the application for from the free version. So here on screen you see the login. Mauro is also posting it on the chat. So you can log in and unlock all the features both in Revit and Rhino. I'm gonna show you in a minute where to insert the username and password if you don't know what it is, of course. So let's maybe jump straight to the actual scene here. Okay, so here I have my Rhino file with the BEAM panel available. If you don't have the BEAM panel visible after you install it, either you open a new Rhino document, because the first time Rhino will launch the plugin, it will not attach the doc here on the right, so you can just open a new document, or just go to the option wheel here on the right and then select BEAM from the drop down and lock the panel here attached to the main properties, layers, etc. panel. To insert the license, you can either click here on the panel on this little icon, and then you can just insert the username and password. Or if you are in Revit, you look for the MKS BEAM tab, go here in this slide out menu, pressing the license button as well, and you have the same interface where you can log in. So if you have both software already open, you might need to log in both times. But if you only, let's say, open Rhino, you will log in, and then you open Revit, it will pick up the license, so you will be unified. Okay, so let's move on and start seeing how to work with this tool, right? So the main idea, as I said, is that you can insert data to objects, and so add BEAM properties to them. And here I have some loose geometry. I'm using the file module from the Rhino folder in the drive. If you cannot access it, let us know. Okay, so if you open this file, it's a Rhino 7 file. We can downgrade it, possibly, if some of you are using Rhino 6. And save it, but the idea is that this panel will be our main platform to insert data. Okay, so these objects, I mean, rendered mode, so it doesn't have any material assigned, anything, and the panel is now showing a blank state, so no objects are selected. As soon as I select some objects, the panel will start suggesting what I can edit from this object. Okay, so first, of course, I can add a family, I can add a subcategory, I can add a material, and I can add some data. And this data is only visible in Dynamo for some Dynamo workflows we're going to show later on. But let's start attaching some material. So there are a few ways to do that. If an object has already a material assigned to it, either by layer or by object, it will already show up here in the panel. This object doesn't have any material, so I can just open this dropdown and I see all the Rhino materials in this document. I can also type and I will get some suggestions. Okay, so for example, I will assign a brass material to this object, and you see a brass material is actually applied in Rhino itself. And I can do that for all the other objects, but I will show other ways. For example, I can say that everything in like this object inherit the material from a layer. Okay, so if I say use layer material, now it's glass, and if I click it in the BEAM panel, now glass is showing because it's getting the material from the layer. Alternatively, I can also select this object and then assign a material directly. For example, I can pick aluminum here and will be assigned to aluminum. And so I can now see aluminum in the panel. So 3 ways really, by layer, by object, or using the panel, you can do that. If you have a material you want to add from scratch, and if you type some material that doesn't exist, for example, I can type a new material, press enter, a new material is actually created in Rhino. So if I go to the material, wait 1 second, I'm just gonna put up my material tab. I see now a new material here, and I can amend the appearance with a new color. Okay, so the panel will create new materials if you type one that does not exist in the document yet. The best workflow would be to have the same materials as in Revit, and just the name is sufficient. The appearance can be different, but of course, ideally it will be the same, but the name is important. When we do export to Revit, if the material doesn't exist, it will be created, but if the material already exists in the document, you will use the material from the Revit document. So you can make sure, you can be sure that if you put brass and you have a brass material in Revit, it will pick up that material. We have also ways to import materials from Revit, and we'll show later in the presentation, okay? But now I started adding some materials to these objects, and stop me if I go too fast, sorry. There's a bit to show today, so I will move on, but if you have some doubts, just stop me or type in the chat, slow down. I'm happy to do that. So next, what I'm gonna do, I'm gonna add some subcategories. So glazing for this piece of glass, and also maybe cladding for these cladding piece here. And the subcategories, speaking about the Revit workflow, they will be created in the Revit document if they don't exist. If they do exist, of course, it will pick up the existing subcategory. Okay, so now I added materials and subcategories to these objects. So what I can do next, I can select all these objects and assign them to a family. So I'm gonna call this family module, press enter to create this family. Once the family is created, the panel evolves and starts showing the properties of this family module. Okay, so here in this little tab here, I have only the object properties and the family, and then this family category and the parameters are actually they actually belong to the module family. So no matter which object I select, I will always show those properties. And I don't have to select all the objects to edit the category. I can just select one, so it exposes the family, and then I can change, for example, the category to furniture, and I can add a comment to the family, and no matter what object I press that belongs to that family will show those parameters and categories. So by default, each family has a series of standard parameters, comments, mark, and work set. So there is no distinction between type and instance parameters from Revit, like they're all together. And as long as this parameter exists in Revit, it will be populated. BIM will not create new parameters. So the parameters need to exist, either built-in parameters or project parameters created from scratch or from a shared parameter file. But at any time, I can add new parameters as well if I want to add. So, for example, I can click here on the P button on the panel, and it will show me the project parameters in this file. Actually, by the way, I forgot something. So all this metadata that we are attaching to the objects is actually saved in the Rhino file. So if tomorrow I open this file, I will be able to see the same information attached to it. Also, if I copy and paste objects from one file to the other, it will carry the information with it. And I can even create a template file with a bunch of parameters. And then if I import this file in another Rhino file, it will bring those parameters together. So it's kind of this BIM data is actually inside the Rhino file and can be maintained during all the design stages. And everybody that opens the file and has the plugin is able to access and modify this information from the file. Okay, even if they don't have a license, like this is completely unlocked, and you can make BIM properties in the files. Okay, so let's go back to the parameters. So I'm going to add a parameter now. And this parameter will be, for example, the keynote parameter, which I know exists for all the families, right? And then I have a choice of which categories I want this parameter to appear in. So, for example, now I'm going to just say all the categories and press OK. I have this keynote parameter added. I can edit it as well and remove some categories if I want. on a later date. I can even import from a share parameter file. So I'm gonna do it now. We have put in your folder a share parameter file should be in the Revit folder. See share parameter. If I open it, I will have this interface where I can select a group and pick a parameter I want, for example, MKS units. I press OK. I say OK, all the categories. Actually, let's make it just for generic models. Press OK. Now I have MKS units and Keynote added to this document. Press OK. Go back to my family. And now I see Keynote, but I don't see MKS units because it was not added to the furniture category. So if you have a parameter here in the list and you cannot actually see it in the document parameters, you can actually go to P again and then edit the units and add all the categories. Press OK. I go back to my object and I have MKS units available. Okay, so let's just add Keynote, and I'm pretty much done for loose geometry, right? So there is a workflow also that uses blocks. Now we're gonna just work with the loose geometry, model the in project coordinates. Okay, then we're gonna see how to make like family-like models. But now I have this geometry. I'm happy with the materials. I'm happy with the subcategories. I created a family. I added some properties and I can edit them with the panel. Another way to edit the parameters, for example, let me create a couple more families just to have some more content to show. So I'm gonna make these a cone family. I'm gonna make these a box family. Okay, now when I press Q here, I have this schedule-like interface where I can see the families in this document. I have my box family, my cone file, module family, or the parameters. I can still edit the parameters from this interface. For example, I can change this category. I can add a new comment and so on. I can even analyze the document and check, for example, the total surface area of this family, how many objects it includes, and how many instances I have of this specific family. This is a distinction between families created with loose geometry or with blocks. If we have blocks, we can have more instances of the same family. But if it's loose geometry, only one family per document with random objects around in the document, okay? I can also export these to CSV, so I can open it with Excel. So if I have a lot of data, a lot of properties I added to my document, I can extract them and actually work with them in Excel or use them as a table somewhere. So I can also change the units and the precision of the area if I need to. And so this is kind of the first step in having a bit of BIM data inside our document, and we can extract it and visualize it and edit it in this table-like format. Okay, we're gonna go later on talk about the instances. Now, I can also select the families, so I can visualize what we are talking about. I can select more of them, and the app will zoom extent on those objects. Okay, so now I have these three families. And another way to visualize what families I have in the document in a quicker way. For example, now I want to export this module family to Revit, and I can either select the objects I know belong to that family, but I can make mistakes. For example, I can select by mistake this cone if I'm not careful. So another way is also to go to the F button to display all the families in the document, and I can search for my module family, press select, and it will be selected for me. I can select also multiple families and select them. So if I just want to select the module family, I can do that with this interface, press close, and I'm sure 100% I selected all visible objects that belong to this family. If they're hidden, they will not be selected, which can be used also to have different versions of the same family. So you can have the same family with different objects hidden in different layers, and it just exports. You just export different objects based on the visibility. Okay, so now we're gonna use the standard BIM app. So here on the bottom, we can see our apps buttons. So I can press BIM, and this next interface will ask me an identifier of this export. So this is not the family name. I can export as many families as I want in one export. So this is just an identifier for me to understand what is included. So BIM works with an archival system. So there's a cache where all these exports are saved, so I can access them on a later date. I can go back and forth imports at any time. So this is just an identifier. I'm going to start saying that this is the module v1. Okay, so I know it's the module family and it's the version 1. So press BEAM and it's exported to my local BEAM directory. So these files are saved on your machine by default. So these buttons here are meant to access these files and also to set custom directory. So in the default directory, which is here in my local BEAM temp folder on my computer, I can have a maximum of 50 files in this folder. Okay, so to save this space, and I can set any folder I want though. So if I go here on this button to set the BEAM directory, I can copy any path I want and save the files to that directory. And more users can do the same, so they can read and write from the same directory without having to every time browse for a folder. You can say, I'm working on the cladding, more people is working on the cladding. Maybe I want to send a file to some other people. Maybe the designer wants to send a file to the BEAM coordinator. So you just point to the same folder and you can BEAM. If you BEAM with the same name, you will override the old one so someone else can pick it up. And you have an unlimited amount of BEAM files you can have this way. So you can organize your files and work on different projects and at any time. But when you're working by yourself, you don't need to archive these versions. You can reset to the default directory by pressing this button, and it will be working again on your local machine. All right. So that being said, I created this BEAM file, and I can go now to Revit and start working with this import. So as I said, the BEAM tab here, MKS BEAM, is available in this ribbon, MKS BEAM. I can drag this out if I want, so I can have all my Revit tools available, and I have my BEAM apps always visible to me. And we're going to use BEAM, the blue BEAM app, which is meant to import loose geometry in the file. No, so I can press BEAM, and now I have this interface that has some settings. So first, starting from the top, I have my help button. So if I click this, it will send me straight to the wiki where I can actually see more details about this app. We have made this wiki so you can even rehearse what we've done today. Everything is explained with videos, and there's a lot of information that is also important to read. It's not a very long wiki, so have a look while you're using the app. Has a lot of hints and workflows explained. Okay, I have still the same buttons here to set the directories. If you set them in Revit, it will be set automatically in Rhino. So it's just one settings. You can change either way, and all of them will be updated. So Revit, Rhino, and Dynamo will be synced automatically. You don't have to do it each time for each app. So here on the top, I have a drop down with all the exports I have done in chronological order. So the top one will be the latest one, and module v1 is the one I just exported. So it's pre-selected for me. So I know if I export, I can go here and see and have immediately the latest one. If you're working on a shared folder, you might see someone else beaming, so maybe you have to go and choose your own file from here. We have some settings here that we can explain later, but I would just leave the default settings for now and use internal origin as my import settings, and just go ahead and press BEAM. So now it will create this family, place it at the same location, apply the materials, apply the parameters, and everything that we have assigned in Rhino. Okay, so now this is completed. When I go to have a look, I have my geometry, it has the materials. It's called, it's a module family, it's a furniture category. It has my comment one here available, and any other parameter I will have, like for example, the work set or other parameters in this file I can assign. When I'm assigning parameters, it's important to keep in mind the type of parameters. So if I have a numeric parameter in Rhino, I can only type numbers. Okay, so if I type some text, it will not work. Also, I have to be cautious of the units. So this file is in millimeters. So any number I type in any numeric parameter, I need to put the right value. So if it's 100 millimeters, I have to type 100. If I scale the file to meter, I need to be careful of changing these values. So best practice is always to work with the same units and never scale the file. So you don't make mistakes, but be aware of that units matter, and also the type of unit. So if it's a text, you can put anything, but if it's a number, you need to put numbers. If it's a yes and no parameter, you can type yes and no. in the field to apply the parameter. Okay, so now let's see. Also, I should have my keynote inserted as I wanted, and also all the materials that are included in this family come with material parameters, so I can edit the parameter from the project. So for example, everything that is under brass will be in the material 1 and so on. So this by category means that some objects didn't have any material assigned. So now if I want, I can change the material from here without having to re-import or without having to open the family directly. Next, let's see how the family is inside after this import. So if we see here, I have my material parameter assigned to brass, my cladding subcategory. Geometry is somehow editable to a certain extent. I can even cut the geometry with some voids if I want, and also combine geometry, right? I can import Rhino geometry inside any family and combine Rhino geometry with Revit geometry. So let me just trim this guy, make it a void, and then cut it. You can see I'm able to still edit this geometry. And BEAM works also in family environments. So if I am in a family, maybe I have other things. For example, let's say I have this volume and I want to import that family. I can just go here. I have my list of beams. There are no settings because it will just straight away import the solids. And then I can press BEAM and add the geometry to an existing family and thus combine Revit and Rhino geometry. Okay. So now that I created this family in Revit, there is a link between Rhino and Revit now because the family exists in both platforms. So if I go back to Revit, to Rhino, and let's make some modifications. For example, I want to make this longer. I will change this to aluminum, and we'll also add a new piece of geometry. I just need to make sure that I add it to the module family as well. Then I can go ahead and use F if I want, double click. So I have everything selected and I don't make mistakes. Let's change comment, put comment 2. Also change the keynote value of this family. So now I can press BEAM and say this is my module V2, okay? Press BEAM, it's completed. So when I go to Revit, I don't have to delete, I don't have to do anything, okay? My file maybe is huge, there's a lot of stuff. I just can go to BEAM, make sure I'm selecting the BEAM file I wanna use to import standard settings and press BEAM. And it should update my family with the new geometry, with the new materials, with the new properties. So select it, the module family, my comment 2 is here. If I edit my type, I have my keynote here. The material parameters change because now I just have two materials assigned and objects without material in this family. And if I'm not happy with the results, I can always go to BEAM and go back to my V1 import, just press BEAM, and it will update the instance to that version. So I can go back and forth and keep updating my files. I can keep these as an archive. And compared to maybe other workflows, it's a bit easier to have this kind of archival than having to undo a lot of operations or to change my script to go back to the version I had before, and without me having to save all the Rhino files each time, because maybe I have a big Rhino file, but I just really want to archive these objects, that I don't want to create a backup of unnecessary files, okay? Another way to use BEAM as a family. So here, as I said, we imported in project coordinates. So this family will have the insertion point of the project because that's where the loose geometry was. Another workflow that you can do if you create a new family, for example, here, I can use my Rhino files as families. So I'm just gonna open a new file. And this time, instead of modeling in word coordinates, in project coordinates, never modeling word coordinates, okay? In Rhino, always in project coordinates. There will be a master plan file that will take care of the surveys. So if I'm making a family, so I'm modeling 0, 0, like I'm modeling a Revit family. And I can then assign this, make it a name, I'll call it box as well as a generic model. And I can work on this file, add more content to it. Maybe I'm gonna add another box, just add it like this. And when I'm happy with these results, I can just BEAM it, okay, box. Go to Revit. This time when I BEAM, of course, box is pre-selected. When I BEAM it, the geometry will land in the center of the file. but that's what I want because I just want to import this family. So now what I can do, I can move this around in many locations, change the level if I want. Okay, let's cut and paste these, align to level 1. Okay, so I have my families. Sorry for this fun situation. Okay, so now I have my families here, and what happened is that I can now, for example, change some geometry. Maybe I will add also another box to the box family, and I can just select everything, say new box, go back to Revit, press beam, the box is selected, and when I beam it, it will just update those components. Okay, so basically my Rhino file now is a family basically, and I do the movements of these objects in Revit. The other workflow was to have the geometry already in the project place, so same workflow, but ideally you wouldn't move this one in Revit. So you can do both ways, and you can at any time as well open here if you want. You're just modeling something, you just need to add these 2 pieces, you can export them, don't even put a name, you'll get a random name. Now I am in the family environment, I can press beam and import those components and load back into the project, and I have the same results. Okay, so more ways to do it, and I can have this family-like Rhino file, right? So still talking about BEAM, and I hope everything's fine, everybody's following along. Maybe I can give you a couple of minutes, and if you have questions or doubts, just let me know. Feel free to speak. If anything is not clear or I'm going too fast with this presentation. But meanwhile, while you catch up, I'm just going to say that there are different categories we can use. Some categories are special categories as well. So for example, I can actually make a loadable floor family if I want. So for example, let me create a floor 1 family here. It's going to make it floor category and export it. Actually, let's also make a wall family. Maybe it's a special wall. Okay, now I'm making a very, very standard wall, but you get the point. Okay, so let's also make a wall 1 family under the wall category. Select both, beam it, say wall and floor. I go to Revit, I can import these guys. Okay, wall and floor is pre-selected, so I'm sure what I'm doing. And we create my families. Okay, and these are actually loadable floor families, something that you cannot really do with Revit, but we managed to find a way. Don't tell anyone, but we managed to find a way. And these elements are room bounding. So I can actually do, instead of using in-place components, I can now use real loadable components that I can copy around. I can also pick, let's change the cut pattern of these walls, black. Okay, should be tall enough. All right, so, and I can combine it with normal walls. Okay, so this is a loadable family coming from Rhino, and if I put a room, should be bound. Put maybe in the wrong level. Yes, okay, I'm drawing something wrong here. Super slow. Yes, probably this one is not liking the levels. Let me just like a bit more. Okay. Let's try again. Sorry for my modeling skills. Okay, so now it's good, and I am able to add a room to this geometry. Okay, so now I have a room that is bounded by some Rhino geometry. So I can also do these workflows, cut it with a door, if I have one in this model, okay, I don't have one, and so on. So there are special categories you can use. And later on, we will show also some more advanced workflow that use DirectShape components. Okay, all good so far, I hope. Okay, so coming back, so this is basically the standard workflow for BIM, for concept design, for big objects, but there's a better workflow that we like to use that include the usage of Rhino blocks. I'm going to open another file called tower. Okay, so let me open this file. And in this model here, I have my module family still, but this time is a Rhino block. Okay, so if I click it, go to properties, I click one of these objects, I can see this is a block instance. Okay, so the convenient thing about blocks is that blocks behave like Revit families, because if I edit the definition of the block, all the block instances will update as well, right? So this way I can have a much more optimized file. I can make one change and will propagate in my model. And also you will have benefits both in IFC and Revit in terms of file size as well. So I have a lot of blocks here, and let's see how the BIM panel behaves with the blocks. Let me just remove this tab. Okay, so if I go to BIM now and I click one block, the panel is a little bit different this time. So it has, it doesn't have the object properties because I'm selecting the block, and the block only has a family field available, right? So if I change this value, and this value is the block name, I'm actually renaming the block. Okay, so when I create a block, the block name will be the family name. So let's say I'm gonna create a new block here with this insertion point, leave it block 1. When I click it, you see block 1 is the family name. If I change these to block 2, let's say, and now I select it and go to properties, I actually renamed the block name. So just make sure you have proper names, and you can also edit it here from the panel. Another thing I can do, I can change the category and assign the parameters as always, as before. And when I edit the block and I click the objects, now I am able to access subcategory material and data of these objects. If I had, so the best workflow will be, they're all assigned automatically to this family. And so if I have materials assigned by layer and I create blocks, I have automatically already assigned the material and the family to the objects. So that's the easiest way. While I am inside this block and I keep adding geometry, I am sure that everything that I add will be added to that family. Okay, so I can then select these guys and maybe say these are made of glass. Let's go to rendered mode just to see. Okay, so I have my materials also assigned to these objects, and they're automatically assigned to the family because when I select them, all of them are selected and they belong to block 2. Talking about parameters, there is a distinction because now we can have instances of the same object. We might want to have different parameters for each object. All right, so that's when these checkbox come into play to instantiate the block. So if this is unchecked, all the parameters I add here belong to all instances of the block by default that are not instantiated. So if I copy this block around, see comment here, comment 1. So this has comment 1, I click the other block, it has comment 1. But if I want this block to have a different comment, I can press instance, and now this will have its own set of parameters. When I click this, it has comment 1. When I click this, it has comment 2, and I can switch back and forth between the parameters at any time. Okay. Another way to edit this parameter, when I press Q, I see I have my list of families. Okay. And you see block 2 in the family tab will show the default parameters of this family. Okay. I can also query the file and ask for all the areas and count. Let's see what changes now. Okay. So now I see, maybe I have to remove some parameters. 1 second, so I can see better. To remove some of these. Okay. just can remove, press Q, a bit more compact. Let's say areas and count again. Now you see that because this file is made out of blocks, it's a little bit different. So I have the total object count, which is a global count, not for one instance, okay, for the whole count, same for the area, the total. And then the amount of instances, these are actually how many blocks I have of this type, all right? And I will see the default parameters of this block. If I want to edit and visualize the instantiated parameters, I can just click instances and it will look for the file in the file for all these instantiated blocks. And I can see I just have one instantiated blocks, which was this one. And actually, I can actually even select it to make sure that this is the one I'm talking about. And you see I have its own parameters that I can always edit here, changing values at any time. So I can say this is comment 3. Okay. When I press OK, now this object has comment 3 added to it. So I can use different parameters for different versions and instances of the block. Okay, so hope it's all clear till now for the ones following along. So now what I can do with these blocks, I can export them to Revit, of course. That's what I'm going to do. So I have one way to do that. I can couple of ways to do that. Select everything, but no, let's use the blocks app and see the options I have. So I click blocks and I have two options. Pick blocks manually, which basically allows me to select any amount of blocks I want from the file, press enter and go straight to the export. Or I can press blocks and pick by definition name. If I do that, I will have the list of top level blocks in this file. So blocks that are only nested will not appear in this list. And I can even have a preview of these blocks and have a look what I am selecting. I can make this a little bit bigger so you can see better. So I have all the blocks in this file. And I can say I want to export these two types, for example. But also to make sure of what I am selecting, I can click on preview selection and I can see in real time what objects I'm gonna select when I export. So let's say I want to export module 01 only, press OK, and I go straight to my export dialog, press enter again. Yes, so you don't need to press every time the button, just press enter to go straight to the final steps. So go to Revit now. I have a bunch of levels here. So instead of using BEAM, because this app was meant to import loose geometry, okay, or import into families, with blocks I can import Rhino blocks. So the interface is similar. I have my help here and my folder buttons. I have my BEAM list of files. Cover is pre-selected, is the one I just exported. And then I have a few options because the workflow kind of branches in three ways. So one is we want to import the geometry and place these blocks. Then we might want to just place a block or just to import a block. And when I place a block, I can place any block. And we'll see that in a minute. So first, we want to import this family in the file because it doesn't exist, and also place the instances. So it makes sense that we have import family on and place instances is checked. I'm going to use internal origin and just press BEAM. And the app will now first import the geometry, you see with the blue bar, and then start placing my components. I can zoom around while it's doing that, so I can have a look what's going on while Revit updates my documents. So I had like roughly 176 instances of this block. So now it's getting there in a few seconds. Okay, completed. 176 objects, no failure. So I go to shaded. I can see now that I have my whole tower. When I click one object, you see this is my module 01. It has my parameters if I added any. And if I do select similar, I have 176 instances of this block. What is nice about blocks compared to loose geometry is that the insertion point of the block will be actually the insertion point of the family. If we go back to Rhino and I click, I select one of these blocks, change my gumball to be aligned to object. So you see the insertion point of the block was here for some reason, but I could have had it in the center, whatever is more convenient to me. Same in Revit, the insertion point of the block is the insertion point of the family, and this is also used to assign this family to a level in the document that is the closest below the object. So for example, if I pick one of these families here, select this guy, I see that the app found out that level 29 plus an offset of 1 meter was the place where to assign this object to. So if I have components that go in different levels, this app will make sure that if there are no overlapping levels, okay, if the file makes sense and you place them in the right position, you will assign them to that level, which is super convenient for scheduling and other data extraction, and makes the file much more precise. Okay, so I can put a lot of furniture on different levels. I can put facade components on different levels, and the app will do this automatically using the block insertion point as the point where to calculate these. Okay. So now the workflow I want to do, I just want to place one object. So I don't need to import. I'm happy with these results. Okay, actually, I just need to import a new version of this family. I want to make a modification. Okay, so you can go to this block and edit one of them. And this time I want to change the material to aluminum. Okay, and also I want to, now I didn't change the color because I'm not in edit mode. Don't worry. So, and also I want to add, let's say I want to add something different. I snap correctly. Snap. So let's say I add this piece of geometry here. Okay. I want to add this guy to this family. So when I press OK, of course, it's added everywhere. Maybe it's not the right family. Let me check. So module 01, sorry, this guy. So let's add piece of component here. Be careful. It's crammed. Okay, so let's add this guy here to the center. That's okay. See, it's added to all of them. I don't have to assign family name and anything because it belongs to a block. Now, let's export this guy. So I have a few options. I can still use the same interface as before. And or I can select just one of the blocks. Okay, module 01, press blocks and say this is my module 01 updated. Just need one to get the geometry. Okay. Go back to Revit, and this time I'm going to use blocks. But as I select my module 01 updated, I just have to untick place instances because I just want to import family. Okay, so I press BEAM, the app will go ahead and update for me that block. I could have selected as many blocks as I wanted. Okay, so now if I go have a look, I have my new version of this block. And same with the standard BEAM, I can also go back in time to my tower, first version, don't place instances. I press BEAM. They go back to that version. Okay, so I can keep doing that and go back and forth options and have my archival in my folder. Okay, so far so good. Maybe I can give a couple of minutes for anyone that is trying to do it. If you have any questions, meanwhile, please let's give it a little bit. So Suleiman is asking, can we use it like a link file? This is a link. Well, this is already a family, which is kind of a link if you think about it, no? Because it links to another file that is an RFA file. But what is your question about if you can like synchronize all the families or something similar? You can maybe expand on your question. If you have a microphone also, feel free to talk. But if you have any other comments, please let us know. So yes, I hope everybody's on par with this workflow. Let's move on and say, let's say that I want to just place a component now. Okay, so I can pick it from here, and let's go back in time once. Now I want to pick one of these modules one. One second. Let me just... Okay, so let's say I have this block, and I want to place it in the file. So I can maybe rotate it this way. Why not? Okay, it's much more simple with the Rhino Gamble. That's what makes it very convenient. And now I want to place this component. What I can do, I can select this component, press blocks, and say new module position. Press enter, and it's done. Now I go back to the Revit file, go back to blocks, and I have an option here. So I can import again the family and place it, but it will be a waste of time if maybe the family is complicated and you will get the file to regenerate a lot. So I can use another option. I can use existing. When I do use existing, I have a list of families here available in the document that I can use. And this is a hint of what you can do with this tool as well. But let's say I would just want to place module 01. That's the family I want to place. And place instances is, of course, always selected. Okay. So when I select a family from the drop down, there will be this banner here that will tell me a few properties of this object. And this is important for the type of block transformations I can do to this family. So by default, any family imported with BEAM will be work plane based, so it can rotate in any direction. Okay, so all the transformation I can do to this block, I can do any. I can rotate in any axis. I can translate it in any direction. The only thing I cannot do is scale the block. Scaling the block doesn't work because you cannot scale Revit families. So be aware of never scaling the Rhino blocks if you want to do this workflow, because Revit families do not scale. So if I select other families, for example, let me just purge this file from these windows from another session. Okay, clear up a little bit. All right, so if I go to blocks and any other family, for example, baluster, it's always vertical and not work plane based, which means that if I have a block that is going to place this specific family, I cannot rotate it upside down. And this also happens with some wall and floor families. They just don't work. Okay, if you have a wall category or floor category, they will be always horizontal. Okay, there is a bit of limitations on what you can do to this category. So this cannot do either. So you can just rotate X and Y in the XY plane, up and down. But with the module 01, I can do any transformation. So I can see here is work based. When I click it, it's much faster because I don't have to import. I'm just placing this instance, and I have this block placed in this weird position. It should be quite difficult to achieve, and is also assigned to the level that makes more sense. All right. So I can place imported families, but I can also place any family. I'm gonna see that now. So what I've done so far, just to recap, so I was able to import and place a family. I can just import a family, so update the symbols of the families. And I can also just place any family using the block transformations inside my BEAM file, right? And I can combine these with native families as well. So for example, let's go to the sample file. So I am in I'm in the sample file now, and let's make something that is maybe not super exciting, and select some chairs and some table just to isolate it. Just one second, let me just send a message. Okay, so now I have this geometry in this file that I want to use as a reference and do some stuff in the Rhino file. So let's just create a new file here from scratch. Okay, create a new object in meters. All right, so now I am in this file, and just as a teaser of another tool, I'm gonna use this tool here, Ray, to send Revit geometry to Rhino. So if I click it, I have a few options. Okay, so if you click it for the first time and you have Rhino 7 installed, it will take a little bit because it's gonna launch Rhino 7 in the background of Revit, so we can leverage more powerful APIs. But if you have Rhino 6, you will use other type of techniques and it will be faster. But Rhino 7 will be the best, so you can get the best quality of objects. So I'm gonna check solid elements, so I can pick these elements here, press finish. It's a bit hard to see, but for the ones that are not used to Revit, that's where you press finish. Okay, so press finish now, and I say these are my table and chairs. Okay, and it's completed. Go back to Rhino, and I can use Ray here. Table and chairs, emit. Go to shaded. You can see I have my geometry, and I can use it as a reference for me. Okay, so what I'm gonna do, I'm gonna create a box over here, just to have it as kind of volumetric size. Then I'm going to create a block. Okay, so just press the block insertion point. The name doesn't matter. So now I have one block. It will be my chair. So copy it around. Because the chair is an always vertical family, I cannot make all the modifications I want. So I can just rotate in the XY plane. The XY plane is the blue one. Okay, and translate it. So now I can select these three blocks, say blocks, and say new chair positions. So now I have this exported. Go back to Revit. What I can do, I can press blocks, go to use existing family and pick that family. Let me just remove this stupid profile here, makes my drop down huge. Let's find it. I don't know what category it is. Let's see the name again. Sorry for that, but it's kind of annoying. Back. See, Mauro, maybe you can support me and tell me where is that specific family.
The chart?
No, this tracking huge. If you guys want to also to remove it.
Oh, yeah.
Just gets in the way a little bit. Well, I mean, I had this guy. Not sure where it comes from. Okay, so if I go to blocks, use existing. Okay, I have my list here. I'm gonna pick dining chair 3. Okay, which is an always vertical family and not working in base, so I have to be careful of this transformation. And I press beam, and just places the chairs using the insertion point of the blocks and the transformation of the blocks. And I can do that for any family in my document. Okay, so I can pick maybe this bar chair as well. I want to place it, I can place it at the same locations. I can go ahead and also place, I don't know, this shower piece here. Okay, so I can use blocks to place any kind of family using the transformations of the blocks. There will be a place also in a level based on the insertion point, and I can make a lot of workflows in Rhino to place these components, optimize the placement, and so on. Okay. So before I move maybe to some other workflows with the standard beam and blocks, maybe 5 minutes of a little break so everybody can catch up, and also if you have any doubts while you finish up your exercises, we can try to reply. All right, so just 5 minutes. So it will be different parts. Yes. So they're gonna see mainly BEAM blocks, some Dynamo, and in the afternoon we have adaptive components, reverse workflow, Grasshopper, and then we're gonna see a few examples of some workflows and files.
Yeah. Also, guys, we would like to hear from you and get some feedback. If everything is fine, if your file is working well, you were able to download everything and the data set is working. We would like to receive some confirmation. Don't be shy. Come forward. Okay, great. So Jessica, were you able to do the workflows with the BEAM blue, the blocks, and so on? Or anybody else?
Okay, also, if you happen to have Rhino inside Revit installed, be aware that you might require a few extra steps to operate. There is a bit of a limitation on how many Rhino instances can run in Revit, okay? Okay. All right. So John, just to ask, so yes, it is stuck in loading MKS BEAM, but does your Rhino get stuck? Because that's only, okay, so then it's actually loaded. Okay, so it's loaded, it's loading, and then it's loaded. That's it. So no, there will be not a message saying that Rhino has to finish loading. So if you see somewhere here, let me see, the beginning of my Rhino session, it just works fine. That's because also if you have Rhino 7, sometimes it might say that, if you see here, no, just say loading, okay, same as with the legacy Rhino render, just gonna say loading, and if you have any problems, it will tell you. Otherwise, it's good to go. If you don't see the panel, as I said previously, you just need to turn it on from the option wheel or open a new file. Okay. Okay, German, perfect. Also, by the way, we're using 1.6.1, so that should be the version you have. If you installed BEAM in the past, well, just update it with the installer. Okay.
So that's good. So yeah, thank you for, I mean, yes, the week is pretty clear and we are glad you like it. German, yeah, it's not a problem. I think at the beginning of we went really slow at the beginning of the workshop. So I think you can just look at it when you get the recording. That's it. I don't see any other message in there.
Yeah. Anyways, just interrupt us if needed.
Exactly.
Let's okay. What do you finish to do?
Good question.
Well, yeah, good question. No, the thing is, like we like to think about it is in a way, what is the difference between Dynamo and Revit? No, right? So you can create wall with both, but one is kind of more of a user experience based application. So you don't necessarily need to do any scripts. So you have interfaces, you click and put your data, click, select. So you don't have to build any script, okay? Same with Dynamo. I could do any project with Dynamo, right, really, no? But who's gonna place doors on walls using Dynamo? Maybe sometimes you do, maybe sometimes you don't. So they're kind of complementary tools. So sometimes you just need to have your file, you're modeling manually, you're doing some operations, you're not using Grasshopper, you're not making any crazy parametric workflows. Maybe you are, maybe you want to save this file, send it to someone else. This person doesn't have the script, okay? You just can select, put some data. BEAM can add BEAM data to the Rhino file. So BEAMifies the Rhino document, so you can have more parameters to extract. So it's kind of a different concept. They kind of do something similar, so which means creating content in Revit, but they come from two different ideas, of one being a series of tools, so you can build your own workflow if you're capable, and that's great. But the other one is basically an application within an application that allows you to manage data and transfer information between different platforms. So what we always suggest is people have both, right? So you can use each tool when it makes sense. Yes, they do look the same, depending how well is modeled the geometry. Okay, so might be some instances where some weird geometry, and we've seen a few instances of that, but it's usually bad model that would generate that. But for anything else, it would just look fine. So for example, let's make some plans out of this. No, so let's say maybe even in level 0 we can already see something. Actually, let's make a new plan on another level and see how those objects look like. If they are, I guess, closed poly surfaces, maybe not. Mauro, correct me if I'm wrong.
Yeah, let's have a look.
Yeah, but you see, I mean, this is the level of detail that we see from the Rhino geometry. Okay, so let's see it.
That's
and
pretty clean.
And I can make consistent color, and that's it.
Maybe so try to override some cut patterns, Mikael, if there is.
Yeah, so I can see the hatch of the material already. Okay, so it's colored. If you go to an elevation, let's create a section here just to see how it looks on the section head. Okay, let's drag this out a little bit, go to section. That's my design. Okay, so depending on how it's modeled, and on the shadows as well if I want, so no problem. If we have a nice model, you'll get good results. So it's all about that.
It really depends. Yes, as Mikael said, it really depends how you model in Rhino, because and something that is really important with BIM is as well assigning the right category to the objects. So if you are using like a wall in Rhino, if you want to assign a proper, let's say a window or something else, then in Revit you are able to retrieve it, to override these categories with the visibility settings. And that's really important when we are working with the 2D plans. To respond to Robert's question, if we're working to create a 2D documentation, we can just use those categories and use the normal overrides in Revit. So if you have a clean system in Rhino of categories and a good modeling system, I think you can really do a lot with this and get a good 2D documentation.
There you go. Let's also write it. What this is a generic model. So let's make it that when it's cut, it's black.
Yep.
Just to make it look nicer. There you go. So this is the kind of visibility you can get. Looks fine. Another question here, German. You're saying you can use your local directory, but as I said before, maybe you were not in the call. You can set any folder, okay, as your directory. If you set this directory to be a cloud shared folder, then it will be synchronized in the cloud, and you can point at the same OneDrive, both more people, and thus obtain the same file, and so you can send to someone just by beaming in a shared folder with the cloud. So just wait for the syncing times and it will just work fine. Okay,
so that really depends on your connection speed generally.
Exactly. But it is possible. It's very fast for if you're sending curves and points to someone else to pick up in Dynamo, then it's super fast. For example, you want to send to even if someone doing fabrication, you can send the Mallion curves, so they can use the Mallion curves. Instead of sending the file, you can send a BIM file, and they can access in Dynamo and do whatever they need to do in their file, sync into BIM 360, and you get your content. So that's also possible. And we've seen that being done in a few projects. For example, in Foster & Partners recently, some people in the specialized modeling group were doing some canopy geometry, and they were not working in the BIM file, so they just beamed in our server the files for the BIM coordinator to pick up and then import the file and update the model and keep going with the project. Okay, so each one has their own role, and file sharing is definitely possible. So Suleiman is asking, what is the transmission error rate in complex models? So we're tracking the fail rate of the app. We have right now 99.9% success, and it's growing because I guess people using this tool is getting more knowledgeable on what works and what does not. There are a few things that don't work. For example, if the model, the object is flagged in Rhino as a bad object, it will not work. But that's because it's a bad object, so even Rhino knows. And even though you can visualize it, then you go into the properties of the file here in details, and it will say it's not a valid element. And if it's not a valid element, it will not export. Also, if it's a non-manifold object, and for example, if I have B-reps, okay, that have one edge that connects more than two faces, that's not possible, okay, in an ACs environment. So now this is a non-manifold polysurface. I can see that in the details. It's a closed non-manifold. So these do not work in Revit, but there is no problem because when I export it with BEAM, let's make a few more objects. Imagine I have a lot of objects I'm exporting, no? Then I go to BEAM and try to beam them out. Say it's completed, but then I will get an error message saying that this object is not manifold, so it's not exported. You can copy to clipboard all these errors, press OK, go here on the panel in the S button, paste these GUIDs, press select, and now I have my selection, so I can find this object. There are other instances with objects that have.
I think it just.
Sorry, Mauro.
No, sorry. No, sorry. I lost you just for a second. No, just to get back to Chi question. This is a little bit another thing that differentiates BEAM to other workflows. These kind of feedbacks for the user. For example, there is an object with an error. There are some mistakes, so we always have some kind of windows to give some warnings or messages to the user to make the workflow a little bit easier in general, also for the experience of the user. So
yeah, for example, if I create a new material that has this symbol in it, which is not valid in Revit, and you try to create it, it will tell you you cannot create this kind of material. So it's kind of an error management that helps. So that's because it's based on user experiences. But for the import success, you have to model properly. It's not perfect, but it's not because of BEAM. It's just because of how the two softwares that, have their own engines running. Okay. So just to last half an hour. If you have other questions, we're gonna do some more at the end. So let's do something different now. And I'm gonna use this file called Pavilion. Okay. And this is another way to manage your data a bit more in an automated way. So I have this little pavilion here. And what we have done in the layering of the file, you can see, let me make this default, okay? We have two main layers, facade and roof. Inside, we have sublayers that represent my subcategories. And then each layer has a material assigned to it. So what does it mean? When I click on an object, it has that layer material assigned to it. So first step, I don't need to assign any material through the panel. No, I can just visualize it. If I can select something, okay? So I can see my timber and so on. Next, we created basically a big layer that encloses everything. If I do select objects, I'll select sublayer objects. And see my facade actually includes all these objects and they are assigned to different layers. For example, this one is assigned to skirting. This one is assigned to mullions, you can see, and so on. So what we made it that if you have a nice layer system, you can go with BEAM and use the transfer Rhino data button here. So I can press it and I will have a few options. So I want to create for each layer a family, and everything that is in that layer will be assigned to that family. And when I do that, I have a few options to use the top layer. Okay, so the most upwards layer in the list. I can use the actual layer the object is, or I can concatenate the root layers and the actual layers as one big name. Now I'm going to use top layer because that's what I set up in this file, to have the top layer as my family. And then I also want to have the actual layer where the object is as my subcategory. When I press transfer, and now I go select one of these objects, they are assigned to a family named A roof, which is my top layer. And the subcategory is the layer where the object is. You can see here on the bottom, edge profile. The material also comes from the edge profile material still. So in one click, really with a couple of options, I was able to assign these families. Next, what I can do, I can go to Q and just change my category, for example, to curtain panels and roofs. Can add a comment, work set, other parameters that I want afterwards. So now I have this set up. And this is a quick way to, if you receive a file, maybe someone is not using BEAM, you want to have it. If you have a proper layering system, it's much faster to create it. And now I can just go ahead and beam this out. Okay, and then import it into my Revit file. So let's remove the section box. Also, just to prove, like, I want to remove this stuff. Also, all the BEAM apps are listed here in the undo. So I can also undo all the BEAM. I know I did a couple of beams. I did a couple of blocks, and I can undo all of these now and go back to stage 0. Okay, just in a second when Revit is done. Okay, now I can go to my 3D view and let's just beam that latest BEAM file I created. Okay, so just wait a couple of seconds. There are a few elements, of course, in this file, but it shouldn't be that slow. Also, if family is already placed, I should be able to see it. Not sure where I had this geometry, maybe in the 0. I zoom out too much. Okay, so I can see already my roof is coming in. And now my facade. It's a fairly complicated design, has a lot of pieces, but now it's coming up. If you close the view and you work on a drafting view, for example, you can get speed much faster imports in different scenarios. No, but it's also good to see what's going on. I can also close these and stop my import at any time. Okay, now Revit is loading the family, and sometimes it hangs, but depending on your machine, it's more or less fast. So you can see now I have my objects. So I have 2 families. One is my roof family, it's called A roof, and then I have my facade here, it's called A facade. I edit the family. You will have again all the properties that I wanted. Okay, so I have my mullion piece of geometry and so on. And because this is a different type of category, it uses a different template. Okay, but I can schedule them and so on. Also, let's see how it looks in plan. Yeah, Mauro?
So Mikael, I think it would be good to show, to mention the difference between importing a family as a loose geometry and a block in terms of positioning of the geometry, because you know, in this case, when you are rotating the object, it's slightly more distant from the origin. And I think it would be really nice for them to understand that that's why the blocks are super convenient for the placement. I think this can be nice, just because I'm seeing,
using loose geometry is convenient because it's faster, but of course using blocks is the best workflow because you see the insertion point of the families here, while if I had used a block, it would be in the same, using the block insertion point, so the rotation will be not based on the center of the file, but it depends on the stage you are and what you're doing. Of course, different workflows are possible, but we always suggest to use Rhino blocks as much as possible. To make some other workflows here, actually, let's Control Z so I don't have too much. If I just isolate, so for example, it's much easier to just say roof, close, isolate. Okay, so I have my roof. Let's imagine I have this panelization. Hide a bunch of stuff. Okay, so I have this panelization. I think there's nothing there. Okay, imagine I have all these panels, right? And I want all of them to be part of, to be of the same type, but I want to schedule them and have them individually. So what I can do, I can, now that I have this roof, let's call it panels, okay? And remove the subcategory, oh, not delete the objects. Okay, I can remove ceiling, maybe change the material to aluminum this time, okay? Now it's made out of aluminum, depends where you are from in the world. So now I have these panels, generic model, maybe I can say carton panels if I want, okay? Change the category here. So what I can do now, I can export these and say panels, export it. Go to Revit, and when I use BEAM, one feature I can use, I can force to use system families, which are DirectShape components, let's say, so not editable families, they're not loadable, but they can have different geometries using the same family type. And then I'm gonna select split geometry because they all come in the same family, but I want actually each individual piece of geometry to be separate, and it is great for panelization. So when I do BEAM, you will see somewhere in the file, my panels coming very quickly. It's completed. Now I can select each individual panel, I can tag them separately, I can schedule them separately. They're all of the same type called panel. Okay, I don't know if select all instances should work as well. See, I have 81 panels of the type panels, but they are all individual objects. They don't appear in my project browser because this is only for loadable components. These components are not visible there, so I will not put a lot of components if I wanted to name them individually, but these one have the same name. I can schedule them, count them, tag them separately in a view. Let's see, not sure if I have any. So if I change my view range, put it up, meter should be okay. Nice, sorry. Let's say unlimited. It's too much. Plane is above what? This, okay. Is unlimited. Top unlimited. Okay, finally. So I can see now I have all individual panels. I can move them around or delete some of them. I can also tag them. Not sure if I have tags here to use. These files are a bit empty. No, okay. Well, anyways, I would be able to tag them and individually. It's good for panelizations. It's a good workflow. So what I've done, just recap. Super slow this file sometimes. Or is my Revit, I guess. I'm sharing, recording, using my webcam. It's kind of too much. So what I've done, I chose system families, and then I use the split geometry property here to do it. These objects, they don't update automatically, so you have to delete them to replace them. But if you are very confident that you are not making mistakes, you can just use the first update, which will delete all the objects of that type before re-importing all of them. So if you are sure that you always have these panels and you want to replace them, you can use force update and it will remove them and place the new ones instead of them. But it will lose, of course, tags and all. With the loadable families, every time you update the components, you will not lose the tags, but you will keep all the tags and properties that you assign. You can also decide when you update BEAM to not update the parameters in case you modify them in Revit and not in Rhino. This by default is on because ideally you should have always updated, but it can happen in the project. If you just want to update the geometry, you don't care about the parameters, maybe they are maintained in Revit, so you just remove update parameters, okay, to make it happen. So clear so far? Just keep a couple of minutes to see what's going on, and then maybe I can show a bit of Dynamo after this. So just 5 minutes of break. I'm just gonna clean up my file, and then we can move. Also have another example to make. Meanwhile, we're gonna open the 5C that you're gonna use also later on. Okay, so in the project file, there is this master plan here. We have created this context, but just ignore it. Okay, so this is the context, and then importantly, we have this massing building. So this massing building is cut with some floors and has this shape, and it's called building mass, and is of mass category. In Rhino, I have the same family, so it's called building mass, and it's a mass category, and I want to now get this geometry into Revit. So what I can do, I can just say, give it a name, export it, go to Revit, just press BEAM, CT is pre-selected, and then I can just import it. Okay, now I have my tower updated. It keeps the floors, keeps the tags, any property you have, so you can do that. I can keep going, update the tower, export it again, say CT2, or I can use the same name to overwrite it if I want. If I want to keep an archival, I can keep doing that. I can update it again. Get my shape, maybe I don't like it, so I can go back to CT and update it. That's it. So also for massing, it's very convenient that you can do a lot of towers, buildings, and update them, and you can keep the floors, the layers, the levels, etc., etc. Okay, so just one comment. You can swap family type. So if I make a generic model family and then I change it to furniture, okay, I can do this operation. Let's see, let's actually make an example just to see something you have to be aware of. Okay, so let's open a new file, just create a little box that I can use here. Okay, so this will be my box family and it's generic models. Okay, so just beam it, box to Revit, beam it inside. So now I have my box here, and it's a generic model. If I change it to say furniture, it would work. Okay, so I can export it back to Revit, beam. This one is selected. And as I wanted now, this family, okay, I have to reselect it, is a furniture family. There are some categories you cannot swap. For example, if I make this now, put shaded. If I make this now mass, and I try, maybe it will not allow me to do that because I cannot swap that template, and the family already exists. So if you see, we'll get an error saying like, it's not possible to load this family. That's because I tried to change the category from mass to any other coming from the generic template. Okay. That's it. Let's move to maybe Dynamo quickly. Then we have a final round of 5 minutes of questions, and then we can have a proper break and see you in the afternoon. So let's open Dynamo. And this is because there are many workflows that might be missing from our app, but maybe you are a Dynamo user and you want to have some Rhino geometry coming from maybe a DWG importing Rhino, or maybe you do them in Rhino yourself, and you want to obtain those geometries. You want to take those curves and those points and those surfaces to make workflows in Dynamo. Now, while Dynamo is opening, I will just create here some components. Let me just turn off grids, etc. So I'm gonna make some curves. I'm gonna make a box, maybe I'll make geometry here, polyline, and some points. Okay, change a bit layers. Okay, so now I have this geometry. I'll also add some data here. This is for Dynamo. As we said, this is exactly something you will use in Dynamo to filter your objects. I can also have names, for example. Sorry, I can also have some names here. For example, the box. Okay, I have different layers and all these properties. So now maybe I can also assign a material. There's no material. I will say new material. I can select these objects and just beam them. Now I'm going to type Dynamo just for me to remember, but it works the same. I can just have any name actually in these objects here. So now when I go to Dynamo, I'm going to create a new one. By the way, so it should be installed automatically, the add-ons. If you don't see it, let me know. You might be using some very, very recent Dynamo library, and you can actually add the nodes if you don't see it just by having this path copied here. I'm going to copy it in the chat. So if you need to add it, if you don't know how to do it, just press plus and paste here the path you can use. Okay, so just gonna type in the chat so you can don't have it, you can use it. Okay, so I have it, so I can go to my history node, and in here we will list all the BIM files that it finds in the current BIM directory. But what I need is the import node, and well, I guess, let's see, it doesn't get an error. So if I put a string, and I'm gonna use this Dynamo one, no? So just gonna type Dynamo, plug it, and now I have my geometry in Dynamo. Okay, very quick. Put in the family, and for you guys at Dynamo, you can open here. You see we have flat lists of NURBS, curves, polycurves, solids. We have the names. For example, this one had the name, the box, so we can filter by the name if we want. The layers they come, the data that we use as an extra parameter, so we can use a filter by key. It's amazing. So we can filter by key and split the objects by any of these properties you want to use, by the layer, by the data, by the name, and so on. We have the GUID, so we can find them and locate them in Rhino afterwards, and so on, right? So even the color, which is a nice touch. Okay, geometry, color. This geometry color. I can plug my geometry and I can plug my color. And now I can see the objects with the color from Rhino the same way. Okay, see black. So I can use now Dynamo to do a lot of operations. I can pick the curves and create some floors. I can pick some points and create some levels using the Z of the points, and all the workflows that are available with Dynamo. And we know, so we just need the primitives. We just need the surfaces and the points and the curves to make those objects and create them straight from Rhino. What is nice is that if we unplug this and I make a change to this geometry, for example, let's move this out and make this a little bit bigger and move this. I can just export again with the same name. And as I go to Dynamo, I plug it again, and I have my geometry updated. And it's very fast. It's very fast. We tested it against other packages, and it's really fast. One thing I would say, don't plug these directly, because you will just go on and import everything. So use a list get item by index, or the best way, if you don't know how to do it, just use a list indexer to access the first element. Okay, so, and you can change, for example, we can go to our CT2 if we want, which is the number 4. If I do that, now somewhere in my document, should be able to maybe see my geometry coming from my beam. Okay, and I can keep doing that in other ways. For example, let's pick also the chair and the table to see how they look. Okay, shouldn't be too bad. Let's see. This is the blocks I used before, so maybe module 1, let's say 11. and I have my geometry from Rhino very fast, and I can use it in Dynamo to do anything I want. I wouldn't suggest to get the solids, but really what you need sometimes is a surface or curves and points that you can use to do. I think I sent this directly to make, sorry, just send the path again on the chat. So you can use points and curves to do all sorts of operations if you want to. Any questions about this? Do you all see the Dynamo nodes available, or just to make sure everything is okay? It seems all fine.
Don't know. Any question or any comment? Any idea?
Now, also, by the way, the Dynamo directory is always synced with the other apps, as I said, so you don't need to change the location of the directory from Dynamo. You will pick up the one that you have set using any app here. Okay, you can use it. Okay, I can even access it from Revit itself if it's the same content. No problem. They're all interchangeable. Actually, one comment is that if I export a block, for example, let's make a block. Base point here, block 1. If I try to import this block using BEAM, okay, I have to export it first, of course. Take these, press blocks, export, okay. Go back to Revit, and for some reason, I use BEAM, and this export has blocks, no problem. It will tell you that this BEAM contains blocks, so use the other app, and the other way around in blocks, you can do that. Robert Otani, yes, and we're going to show this in the afternoon using Ray. Okay, so you can export all sorts of geometry and data from Revit to Rhino, and we're going to do that in the afternoon session. So definitely, it's one thing we will cover.
10 minutes left. If there is any other question, I think it would be nice now to respond.
Also, some people asked this a couple of times, but if you have exported blocks from Rhino and you are in a family environment, let's say the model, I do export a block, I can still import it with the standard BEAM only if I am in a family. And what will happen, it will place the geometry in the center of the file, okay? The same location where it is inside the block. So it's also good that if you have, let's say, then I will reply to your question. If I go to the tower and I export this block, which is in a random location, right? So this block is in a random location. If I export it, say module, I can still go to a family environment. Okay, so I'm in a family environment, and this is the center of the file. If I use BEAM here, it will place the geometry in the same location relative to the origin of the block. Okay, so we'll fall in the center now, probably this is the insertion point of the block. So it will place it in that environment. It will not matter where it is in the project location, okay? So it will be centered. And I can get the geometry here, add it to other geometry. For example, I have a door family. I can create a normal door family and add some pieces of information from Rhino and then load it back. So I can also use BEAM in this kind of a quick way to import extra components and have a mix of families with native components and imported components, even though when these components are imported, they become native because they become real solids from Revit. So there's not really a distinction between them. It's just that if you double click them, they are not extrusions, but they're still solids. So it's the same kind of component. There is no different at all. If you do import meshes, which is something that we haven't covered, Mauro, now that I remember, final
Right.
minutes.
But can I add something to the Robert question about
Yes.
the library? So what we're seeing a lot happening since this blocks workflow is really powerful. What we're seeing, a lot of users are using a library of, I mean, they're using a folder, specific folder or a library of Rhino models and using this as like a family environment. So they model the block. And they model the block in Rhino and then import with blocks to replace all the blocks in a facade or in a project. But yes, what they're building is like a library with all the blocks in Rhino and you know, with the good names, with the right names, and just an object, basically just an object almost per file, and they have these nice libraries. I'm seeing this happening in few projects. I think it's a really nice, it's really good workflow, even though with the blocks, you can even have all the blocks inside one file because they will be imported in the origin of in the origin of the block. But yes, you can, we see happening the creation of the libraries for typical blocks of a project. So definitely is a good practice for us.
Ideally, you can even export the blocks individually into a location on your network, and then you point to that location and you go straight to Revit and import it, and it's just like loading a family, because the BIM file will be your family. So you can go to Rhino, export each block individually, save it in a folder, all these files, and then you go to Revit, point to that directory, and you can use blocks with the list of families from this dropdown. Okay, so each BIM file will be actually one block family that can update the components in your file.
Yeah, so basically you use like Rhino as a family, let's say in a way now as a family environment. You modify your elements, you amend them, and then you bring them in and updating all of them in the same way you update a family into a Revit project, into a project environment.
Yeah, because what happened is that, especially for furniture components, that's very true, not only for special cladding elements, but if you have a furniture object, let's say this chair coming from the Revit example, modeling this in Rhino is not super difficult, but look what we have to do in Revit to make this family happen. Like, it's a crazy volume, like void extravaganza, no? Like to have this chair. Like, this is a bit of a nightmare, to be honest, to manage. And it's a little bit heavier because it has to do all these operations and store Revit has to store all the solids before and after the cut and have this information there, makes it heavy. So if you have this chair in Rhino, you just save it as a block somewhere, export it in a BIM folder, you can import it and it'll be much cleaner. Look at all these operations it has to do. I mean, it's long. Sometimes you get it from the producer, this chair, and you can clean it up in Rhino and get it into Revit with all the materials, like no problem.
Because it's clear that in Rhino, modeling an object like this will be much easier.
And much more precise. Look at the
much more precise.
The tangency here is missing, really. Maybe it doesn't matter too much in this type of objects, but there are other instances where these actually matter in the design. You will see this line, you know? So there are many instances where modeling in Rhino, especially furniture, is the best option. And to keep your files organized there, we can assign materials and so on.
Yeah. And then with blocks, the powerful thing, again, it might be a little bit repetition, but you model once, you model in just an object, you move it all around in your Revit file, and then when you update everywhere. Much easier, but it might be just a repetition, but it's super important. And we see the users in general, the project are saving a lot of time with this workflow. So definitely something to try it out.
Mm-hmm. Just to talk about combining families, like if I open this door, this is a bit, well, we can do this later, maybe, I don't know, but for example, just to make it faster here, I'm just gonna pick this object as a reference, okay? Door frame. It's done. So this is all native stuff. I just need to add some extra information. So I go, not FC, of course. I go to Ray, door frame. I have my frame here in Rhino very quickly, okay? If I need to add some object, let's say, actually, maybe I want to fillet this, no? I want to use fillet edge, which is a tool that really we need in Dynamo. So let's say the radius, let's put 0.05. Okay, so maybe I want to fillet this, okay, my Rhino doesn't block itself. It's a bit too much. Let's make it 001. Maybe too much. Okay, let me just, easier to work in millimeters. But that's it. So let me just try again. Yeah, Rhino is not behaving, so let me just do once. Not sure what's happening. Well, let's make another example here. It doesn't. It's not behaving. Let's imagine I need to add this component. Okay, something more complicated. Okay, but I can just beam this out. Go back to Revit. Beam it. Add my geometry. I can load it back to my project. And now we'll have a native family with extra components that I can add in the project. Okay, so this is made out of both components.
And it can be done for a door, for a curtain wall family, inserting the curtain wall, the curtain panel into a curtain system. A lot of uses for this kind of object and this workflow. Yeah,
we will see more examples of this in the next session. So 1 minute left. Thank you everybody for joining this morning session. See you in the afternoon with the other meeting. And if you have questions also, in time, think about them. We will gonna look at them next session. Should have all received the invite. So see you in half an hour break.
Thank you. Okay, so let's start. So, okay, we're good to go. Again, if you have any question at any point, just stop me, and we really welcome your feedback and questions, so please do. Let me share the screen. Great. So after the first two tools, BEAM and blocks that Mikael has kindly shown to us, we're going to move to the next tool, Ursa. So Ursa is a tool to place adaptive components and family and native Revit families. So let's start from the adaptive components. So we love when we have to deal with complex design in general, and not really, some bespoke design in general. We really love to use adaptive components because they are flexible and they can adapt to different shapes. And also, being basically native family, we can still control the parameters and use them in the Revit environment. So let's have a look at the components that we have in this file. If you scroll down in the family, in your project browser, in the project that we have shared with you, first of all, do you all have the file? Otherwise, we can share again, but you should have in the data set that we shared at the beginning all the files. Maybe only Stephanie has not the files. We can share again in the chat. Mikael or Othman, can you please share the link again in the chat?
Sure.
Thank you. So if you look in your Revit file under the families and under the category generic models, we have two families, cables and panels. So let's drag the standard type of the cable family into our project environment and into our view, sorry, and we can have a look at how these components work. So as we can see, especially if you go inside the family in a second, that this is a very simple adaptive component element with two adaptive components. We can see also the number 1 and 2 in the preview. And if we go inside the family, we can see the component a bit more in detail. So we have 2 adaptive components, and we have an extrusion. I'm not going to through all the details of the component, as this is not a lesson about adaptive components, but you can then, after the workshop or when you want, you can have a look at how the component is done. And just keep in mind, just take a note about the parameters of this component. If we select the solid, we have a material component, a material parameter assigned, this pink one. And we also have a radius. So these 2 are 2 instance parameters. They at the moment are 400 and pick 1. So let's go back into our project. When we select then the component, we can see that we can still edit this parameter. We can edit this parameter radius and pink. So just let's test it if it works. I'm changing to 200. And that's fine. So what we're going to learn now is how to use BIM, and especially Ursa in this case, to import adaptive components based on Rhino lines. So if you open your file adaptives, it should be in the data set. If you are using Rhino 6, it's called adaptives _ Rhino 6. If you're using Rhino 7, it's just adaptives. Okay, at this point, we can start to analyzing what's happening in this Rhino file, and we can start from to assign properties to this line and see how they are done. But first of all, so these components in Revit are being placed based on the number of vertices of these lines. So basically, if we are talking about a 2-point adaptive, we're going to use a simple line. If we're using a 3-point adaptives, we're using a polyline with 3 vertices. Sorry. 1, 2, and 3, or 4 vertices for a 4, and so on. So a way to understand if our lines are ready to be used for the adaptive components exercise, we can just, an easy way is just to select the line and type in what in the command in Rhino, and see what it's and see more details about these lines and the geometries. What is a really good command generally to analyze the geometry, to check if the geometry is valid or not, if a line if a line is a proper line, is a line or is a NURBS, and so on. In this case, we can see under the geometry properties there is a valid curve, is a line with a start and end point. So it's a good fit for us because we can use for a 2-point adaptive. Also, comparing to the exercise that we have seen before with Mikael, when we select the lines in Rhino, we can see in our BIM panel that instead of being a family as a name of as a main name for the object, is called a set. So when we select the lines, they are set as a main name for this object. It's really important to see this different, because in this case, we are distinguishing, we are differentiating between solid objects that can be imported as a solid geometry into Revit and lines. We cannot import lines with BIM. But what we can do is applying adaptive components or sending these lines to Dynamo for a more complex workflow. So in this case, then, we can also see that for the lines, we can still assign custom properties. We can assign, we have a mark from there is a parameter that is filled since the beginning of the creation of the line. So every time we will create a line, we have a mark assigned, and we're going to see in a bit why this is really important. And also we have all the other properties. So let's start to assign some properties to the lines, and then we can see how we can use these properties to drive some properties in the adaptive components. Let's delete these lines. First of all, I'm going to just remove all the parameters that I have so we can start from scratch. So this parameter, maybe for if you were not in the call before, through the P tool, we can see all the parameters, all the custom parameters that we have in the Rhino document. So we can just remove them, and we start from scratch. So now when we select the lines, our set, we can see that we don't have custom parameters, and we can start from 0. So when I select, when I go to the P now, I want to add the parameters that I have in my Revit files. So the parameter that I have specifically for the adaptive components, for the instance parameter. So I'm going to call it radius. Okay. And I'm also going to add material. And okay. Now, when I select the line, I can see that I have these two parameters in here between among the other family parameters. And I can use these properties to drive instance parameter in Revit. So let's take just a few of these lines. I'm going to isolate. Hopefully, it's not going to freeze. When I select the line now, I can start to apply these properties. So this material, we can use the materials that we have in this Rhino file or create a new material. If the material is not existing in Revit, it will create a new material in Revit that we can then amend after the import. Or if the material is existing in Revit, it's going to just pick up the material and use those properties. So let's use brass. We change the radius to 100 for this line, but then just to go a little bit more quick, I can just select few lines and use this as a steel, and using this as a, let's say 500. It's not going to look great when I import, but you get the idea. Then after I've done this assignment of the parameter, I can just import, and the import is basically the same as before for the solid components, just using BEAM. So I select the lines. I click on BEAM. As usual, let's also, sorry, I forgot. Let's also assign a set. We can assign a set, or we can use the existing sets. So if we go to the F tool, we can see that we have different sets in here, or families. So the bottom curves, the top curves, and the edge curves. So I can select all of them, because as we said at the beginning, we like to select with this tool because at least we are sure that we are selecting precisely these families and we are not missing anything. So now they are selected, and I can just use BEAM and call this import. So maybe for who was not there at the beginning, this is not the name of the families. Of the family. This is just an identifier. It's just a code to recognize the specific BEAM file. So I'm going to call this adaptives 1 and OK. Now we can simply go back into Revit in our file. And now we're going to use the new tool for this specific topic, and which is Ursa. So as you can see since the beginning, the interface is pretty much the same. So we have a drop-down menu with all our BEAM files. We have a drop-down menu with all the families and types that we have in the document that can be suitable for this workflow. And also we have, interestingly, a note about all the points, adaptive points that we have for these families. So remember, the lines that we had in Rhino were had two vertices. They have two vertices. So what we want to do is search for adaptive components with 2 points adaptive. In this case, so when we select the 2 points adaptive, we are sure we are using the right component. So I'm going to use the cable. Just out of curiosity, we can go ahead and see how many points the other families have. For example, this family panel with a type glass has 6 points, and we're going to see the workflow for this panel later on. And then we have 1 point families, which are, let's say, classic Revit families. And we're also going to see how to apply those. But let's go back to our case. Cable, standard. it's okay. We have update placement. We're going to see later on how to use this, and we can use, as usual, or internal origin or shared coordinates. I'm going to beam this, and we should see our adaptive components being populated in real time. We can see already that the radius are different based on what we have assigned in the Revit, in the Rhino document. Also, I mean, as I said, it's not looking great because maybe this radius is a little bit too much, but we can see that it's working exactly how we planned, because the radius is 500, and this is what we have specified in the Rhino file. The radius for the edge curves is 50, and the material is pink, and there is only one edge curve, which I have assigned the brass material with a radius of 100. Is all clear so far? Do you have any question? All smooth? Okay, great. So at this point, we have imported our elements. And as I said at the beginning, I mentioned the mark. So the mark is a value that we apply instantly in Rhino once we create the lines, and is a very important value, is a very important parameter, because it's the one that allows us to link the Revit adaptive components with the lines in Rhino. So at this point, we are able to go back into our Rhino file, modify the lines, and bring them back into Revit without having to delete any of our adaptive components. So now let's play a little bit with these lines. If you are experienced in Revit, or even if you're not, you understand that this workflow is much easier to be done in Rhino rather than in Revit, because we can drag the points, we can play more with the gamble, which is great, and something that in Revit obviously is missing, like many more things. For example, let's just to clarify, if I go in Revit and I want to move the adaptive components, it's a bit difficult. Also, I cannot move more points all together. I mean, at least I don't know how to do it. You might know a trick, but I don't know how to do it. And also, there is no really gamble or anything that allow me to model in a 3D view so precisely. So when I go back to Rhino now, I made these modifications. And also, let's change the values again. So the material, maybe I want them to be all glass, and the radius, we can use something like 50 again. And also we're going to apply a comment, just a line for all of them. Okay, so I'm changing properties. I'm changing general properties, and also I'm changing the shape and the position of these components. Now I want to update my components in Revit. So what I can do is either selecting all the lines, and I can do this at this point, or we can also use the F tool. But let's just select all the lines, beam them, and call these adaptives 2. That's it. As you can see, when we are working with lines, the speed of BIM it's very, very fast. It's has increased a lot. So when we go into Revit now, the only thing that we have to do is the usual workflow. So we have a look at our drop-down menu, and we have adaptives 2. Again, we need to select the correct type. So cable standard without 2 points, and we leave as it is. It's very important, but this is checked by default. It's really important that we keep update placement checkbox checked. And I can just beam them. So what's happening, and we can look at this in real time, we're updating all our components, and we don't have to delete them. And this is done. So now our components are in the same location as the Rhino files ones. okay? And all the parameters are updated. Even the comment wasn't here before, and now it's line. So now at this point, I can start to schedule these components and do whatever I want. An interesting, I think we have two questions, or okay, no, just sorry. So something that is interesting about this workflow. So it might happen sometimes that you want to schedule also to place an area in an adaptive component, or you want to place any other parameter. You can, exactly as I've done in here for the comment, you can bring this parameter along in the Revit file and schedule, and it's pretty easy to do. But at this point, we might have another question. Like, okay, I have the adaptive components already placed in our Revit file, but they are not in the Rhino file. So what can I do? In this case, it comes into our help, the Ray tool. And as the question that we received at the first 2 hours, this is the tool that we're going to use to transfer properties and geometry from the Revit file to the Rhino file. So in Rhino, I'm just going to create a new file. Let's change the graphics just to be a little bit more clear. Second, it's a bit stuck. Sorry. Just a second. Hopefully. Well, Revit is still alive. Rhino is a bit dead. So in the meantime, let's describe it a little bit, the workflow. So as I said, there might be some cases where you have the adaptive components in your Revit file, and you want to transfer them to the Rhino file. Or you might have any other geometry or properties that you want to bring from Revit to Rhino. And in this case, we can use Ray. When we open Ray, we can see that we have different options for the imports. We can select the edges of the geometry in Revit. We can select the grids and curves. This is a workflow that we usually use in a 2D plan. For example, sometimes it happens that you have the grids in your Revit file, but you want to be sure that the Rhino designers in your team are following precisely those alignments, and you can use then this option. Or you can use the default, let's say, selection, which is the solid elements. At this point, it's worth mentioning, if you have an element selected and click on Ray, it would just go directly for the solid geometry. So with the pre-selection, keep in mind, you are using the option to select the solid elements. Okay, so I'm going to unselect the objects. Then you can use the adaptive components to export the lines, the construction lines of the adaptive components to Rhino. Or another thing that is sometimes pretty handy is to import parameters and materials from the Revit files, from the Revit file to the Rhino file. And this is pretty useful if you have a library, or you want to move a libraries of our parameters, a library of materials, and you want to have exactly the same names into Rhino without doing maybe typos or something like this. We might add more options for this specific for this specific selection in the future. For example, we might want to export work sets or some more information, but it's still in development, let's say. So let's see if my Rhino is it's still stuck. Okay, let me just close the Rhino file. Let me force this.
Rhino 7 is not as stable as it should, but that's it.
Yeah, it's a bit strange. I mean, I didn't get any error, just got stuck. Okay, but let's open again. It was going to take just a few seconds. In the meantime, please, if you have any question, go ahead. Okay, we have a question. Thank you. Will you make the nodes to connect the structures? So, Aline, are you talking about a specific workflow for structural components or something like this?
Yes.
Yeah, I mean, I think it would be great to do this kind of workflow, and also because, as we said, okay, let's. So this is it's a good point, because when we select a line, when we create a line, and we pretend this is our object, let's say structural line reference lines, we can assign this as a beam or as a structural line, and we can use these to drive these adaptive components. If the adaptive components in Revit, let's go back into Revit and let's have a look at this. So if I go into the family, so now I hope this is correct what I'm doing, but Mikael and Otmane, please be alert. So the good thing is, exactly, if you go into your adaptive components and go to family category and parameters, you can see that we can change the category of our adaptive component to be, for example, a structural connection. So we can use the lines, yes, to create structural components, basically, not the standard ones like beams and other components, but you can still use this workflow to create structures. And if you are, I mean, it depends on your skills on adaptive components. You can use the adaptive points as a nodes to connect the structures. Yes.
If you want to place native connectors, you can still export the curves and open them with Dynamo, and there are many other nodes to create those kind of beams and columns using lines and NURBS curves. So you can do the export and then just use Dynamo to feed the other parameters that are needed to generate those kind of components.
Yeah, exactly. There is a specific component that I have used in the past. Is structure. I think it's structure connection, or is probably beam by curve. Is a node in Dynamo, and you can use that component in Dynamo, that node in Dynamo, to create native components.
We can make an example afterwards. Also, Mauro, Jessica is asking how to create the material parameter. Can you go through it again?
Yeah, of course. So, so Jessica, I don't know if you are using these components that I'm showing at the moment, or you are doing your own one, because this component has the material already in there, but I can create from scratch. In Rhino, inside the BEAM. Perfect. Yeah. Okay. So if you open the P custom parameter dialog, you might find yourself in this situation where you have no parameter at all, or you might have just a few parameters, but you don't have the material parameter. So the easy thing that you can do, sorry, is to add. Okay, you type in here material without doing typos, as I was doing, material. Check all the categories. Okay. Click OK. Now, when I select my line, I can see the material parameter listed with the other family parameters. Just let me know if that's working for you. Okay, great. So, and yes, in this case, as I mentioned at the beginning, I can use either a parameter that I have in my Revit file or a parameter that I'm creating in the Rhino file. But I think in this case, it will be worth mentioning how to import a library of materials from Revit to Rhino. We can show that later, but I think in this case, it might be interesting. So we mix a little bit two techniques. Let's go back into Revit. If we go into Ray, we can select the option parameters and materials. When we select the parameters and materials, we can see that we have listed here in this dialog all the parameters, project parameters that we have in our Revit file, and all the materials that we have in our Revit file. So what we can do, we can just select all of them, and in the usual BEAM way, send parameters and properties. Okay, export completed. Now we can go into our Revit Rhino file, use Ray, and we can see there is a hint in here saying import Revit properties. So we are not, so we are importing only the Revit properties in this case. But if I go back, if I go and explore a little bit the other BEAM files, let's say these Ray files, it's probably more correct in this case, which are, for your information, 3DM files, we can see that we have listed import geometry, so some geometries, and also we have Revit properties. Now, when I BEAM them, I can see that I have all the materials that are coming from that have been exported from the Revit file. And when I click OK, I can see 70 materials imported. Okay, so now why this is useful? Because when I go into my Rhino file, I can see that I have transferred all the materials from Revit to Rhino, and also with the look, with the color, and also the texture. So this is really useful, and especially to not make any mistakes, but also to maintain the aspect of the material. So if we go to our rendered view now, we can select an object, assign the material, and instantly you can see that we have in this dropdown listed all the materials that are coming from the Rhino file. So this would help you to assign the materials. And when I import into Revit, it's just going to use the material existing in Revit for the assignment of the of the material for the object. So I hope everything is okay so far. If you have any question about this last workflow, just let us know. But if not, I'm going to go ahead with the workflow that I was doing about the adaptive components. Okay, I take it for all clear. So let's go back into our Revit file. So as I said, if I have these components already placed in our Revit file and I want to modify them in an easier way into the Rhino file, I can just use Ray, select adaptive component, BEAM, selecting all the components, and just pay attention to this. The finish button is here on the left upper side of the bar. We click on finish, and we can just use the usual name to export this file. And let's call this adaptive lines from Revit, or whatever you want to use. Okay, we click close, and in Rhino we can just use Ray, and in this case we are importing geometry. Our BEAM file, our 3DM file is called adaptive line from Revit, and we BEAM it. And as I said at the beginning, the workflows that involve lines are super fast. So basically, in no time, you have all your lines into the Rhino file, and the name is the name of the type. No, sorry, is the name of the family, and you have the mark assigned. So that basically is can guarantee that we have a link between Rhino and Revit. So if now I still want to modify this, moving, changing all the material to be brass, for example, I can just update this again in the usual way. Let's see also the name in the family. Yeah, we can see that we have cable. So the name for all the types that we have, for all the families that we have, close. We beam it. And we can call this adaptives update. And that's it. We beam it. Let's go into Revit. At this point, we need to use Ursa again. We select our cable family with the standard type. We beam. And as we can see, we are already updating our components in the Revit file in real time without having to delete anything, basically, and also keeping our parameters in here. And this is the final result. I'm pretty sure you can do something that is much more, that is much nicer than this. That it doesn't look really right, but the important thing is the workflow in this case. So we can go ahead to another example of adaptive components workflow and Ursa workflows, unless you have any question. Okay, so I think it's fine. So let's delete this component, or we can even leave in here, or delete. Maybe it makes things heavier. Okay, so let's go back to our Rhino files. You can have a look. You can open the file. So this file was the roof, I think.
Adaptives,
no,
I think.
adaptives. Okay, so let's open adaptives, the adaptive file again. When you open your file, your Rhino file, you will see that there is another example, let's say, another shape at the bottom that contains a little bit more geometry this time. And also the geometry is not just lines, but it varies a little bit more. So we can, when we select the elements, we can see that we have a family, these polysurfaces, this sort of ramp is called family, floor family. We haven't assigned any subcategory at this point. We can do that, but or not. Assigned a material. And also we have some family parameters applied. But the interesting thing about this are about this workflow are these lines. These lines, these polylines have 6 vertices. So what that means is that if I want to perform this workflow with Ursa, I have to use a 6-point adaptive component, which is not really traditional one. We can see a little bit more in the detail how this is done, but it's a very interesting workflow because you can use, basically you can create a curved curtain walls, curtain, curved panels, sorry. So now when we're going to, if we want to check if these lines are proper 6 points lines, we can just type what. I mean, we can type what. On another way to do this is also using the properties in the properties panel. When you select an element and you click on details, it will bring you to this view, to this dialog. I'm pretty sure you know this already, but it's good to show. And what we have in here is a valley curve, which is the thing that is the more important for all the objects in Rhino. And we can see there is a open polylines with 6 points. And this is what we need to make this workflow successful. So now at this point, let's have a look. Again, our geometry, everything is fine. We are ready to use it for our import. And something interesting for this on this workflow in this specific case, our geometry, the solid geometry is under the floors categories. So we're going to see how to create a loadable family of a floor category, and which is something that is not really easy to do out of the box, let's say, in Revit, but it's something that is BIM specific, I would say, and is a trick that is we found out that we've been able to work out in Revit. So what I'm going to do now is I'm going to use my my tool to identify all the families. I'm going to select floors, and I'm going to select panels. And now I can just BIM all of them together. Let's call it ramp floor with panels or whatever. I'm not great at naming elements. Floors with panels, and OK. So now our Revit, our BIM file contains solid geometry and curves. And that's not a problem, because BIM will recognize the object that needs to be used, for our workflow. So for our traditional BIM blue workflow for the solids, and then with the same BIM file, we're going to use Ursa. So first of all, as I said, it doesn't matter if it's a floor category. We're going to keep the option for the loadable families. All the other parameters are kept by default. And we BIM it. In this geometry, also something that you should be aware on this training workflow, I'm using Revit 2022. Still is not really reliable as 2021 when it comes to the geometry import. So in this case, this is not an error. What we are saying is, exactly as I mentioned just a minute ago, we can see that for these family panels, family did not contain any suitable geometry. Points and curves cannot be imported. Okay, it's fine. That's why at this point I'm going to use Ursa. But okay, let's have a look at our import. So we can see that this is a floor category, but and this is something that we are doing only in BIM, I guess. We were able to import this floor as a loadable family. Let's go into the family, and we can see that this is a pretty good piece of geometry. We can still edit it. We can cut voids. We can stretch it a little bit more. We can edit until a certain degree. But now is the time for the panels. So as I said, what I'm going to use is Ursa with our .beam file, and I'm going to look for our 6 points adaptive components in this case that I'm going to look a little bit more in detail in a second, but let's place it and then we go into the family. So it's 6 points, family name, panel, the type is glass, internal region, everything is we can keep by default except for the family and type. So I beam it, and we can see that it's nicely populating all the components. And as I said, with this kind of components with 6 points, the nice thing is you can create these kind of curved elements. Okay. So the result at this point is pretty nice, I believe. Let's see, maybe in another view. You can, at this point, you can document these elements, schedule them, and extract details, whatever you need to do. So now let's see a little bit more in detail these components. These components are in the data set that we sent, so feel free to play with this, add more layers and everything. So if you go into the family, you can see a little bit more the component. It's really important, really important that the order of the adaptive component, of the adaptive points is the same as the one that you're using in the Rhino file. So, I mean, it's super easy to recognize it. In this case, we have 1, 2, 3, 4, 5, 6. And if I look just briefly, our Revit file, sorry, Rhino file, we can see that the lines are pretty much the same. Starting from, I mean, the opposite side, but it's pretty flexible. 1, 2, 3, 4, 5, and 6. So they match. And that's what it's really important when we are doing this kind of workflow. Otherwise, I think you are, everybody is familiar with the strange things that can happen with adaptive components, with pieces that go everywhere. But if you are modeling in a nice way, maybe you have built these components with Grasshopper or any other way, I think everything should work. At this point, so let's go back into Revit. We had a look of our adaptive component. We can even dissolve this one and have a look how it's done. Probably not the best idea right now, but we can stretch it and see how this works. So let's go back into our file, and what we're going to do now is to update all of this. I'm just going to select everything. I can see I have 66 objects selected in here, polysurfaces and adaptive components. So what I'm going to use now, just for the sake of the exercise, I'm just going to stretch it. Let's stretch also in this direction a little bit. Okay. At this point, I want to update this in Revit. What I'm going to do is using the F button. I'm going to, I can even, so in this case, this is just for as a side note. As a side note, we can search the elements, sorry, the families in our Rhino document. So this is pretty useful when you have a big list of items. In this case, I can just select panels and floor, select them, close. BEAM. I'm clicking on the BEAM, the big BEAM button, and call this floor and panels 2 in this case. So remember, this is the nice thing to have a file-based system workflow, a file-based system application. We can go back and forth in time and do different options. So let's go back into Revit. Let me just, it's a bit slow, I know. Let's go back to this, to our workflow. I'm going to use Ursa first, or maybe the floor first. Okay, I'm keeping everything as it is, and I'm going to use BEAM with standard settings. So the first thing that I'm going to do is update the floor. Okay, usual warning. Okay, and now we can update our panels in the same way. We select our panel, glass, everything by default. And as you can see, if you move the view a little bit, we can see that the panels are already coming into place and creating our new, updating our sort of ramp / floor with the panels. Any question about this workflow? Do you use adaptive components in your workflows, or you are more into curtain walls or curtain systems? Okay, so at this point, maybe we can have a look a little bit more at the our last tool, Ray, and then we get a little bit more into computational workflows with Grasshopper.
There is a question from Stephanie, and also maybe we can show the trees.
Yes, of course. Yes. Yeah. What's the question? Sorry, I didn't see it.
If the floor does not work with shafts.
Adaptive will work well with structural elements. Okay.
There's one question. If the floor imported does not work with shafts, is that right? Yes, because only the...
I can't see the question. I think it was a private
it was
message.
A private, okay.
Okay, so, go ahead, you, Mikael, if you want.
Okay. So no, it doesn't work with shafts because shafts don't cut families. And because that is a loadable family that is not cut by the shaft. So you need to pre-cut the geometry in that case. or create a standard floor that will have the limitations we know about. The next is from Robert. No, I mean, if Stephanie, is that clear?
Yeah, that's clear. Thank you.
All right.
Yeah, I mean, there are some workarounds. Of course, if you have a floor in your Rhino file and you have such a bespoke shape, I would imagine that maybe you bring along also the main the void or the shaft you are talking about. Obviously, it would be really, really good if we could cut with the shafts already these kind of floors. At the moment, it's not possible, but you can still. Another workaround that came into my mind is having a void family, maybe, or generic mode and then cut geometry. But anyway, good question. It's good to experiment a little bit more also with these kind of shapes. The last workflow that we can.
Question from Robert Mauro.
Mikael, I think the question is still.
No, it's not. Is adaptive components will work well with the structural elements?
But is a comment or is a question or is a statement? Sorry.
Sure, Robert. Can you expand on your question, please? Statement. Okay, great.
Okay. Thank you, Robert. Yeah, yeah, you can still schedule them and assign to the right category. So I think for most of the architectural stages, unless you are like in fabrication, these are really. I think the workflow is really possible and will work for you. So let's see the last workflow for the Ursa tool, and we can use for this workflow the our CT file. So in your data set, you can look at your CT. I hope everything is good with the files. Okay. So many times, if you're working with a topography or you're using like doing a let's say a landscape project, something that might be really useful for you is using native native trees in Revit, but drive these trees by points, by location specified in the Rhino file. And we have an example in front of us. In this, we want to use these points to place some trees in Revit. If I look at all the families that I have in this file, I can see the building mass that already Mikael shown in the first half, how to import and modify and update. The context, which we don't really need right now, and the trees. The trees are only points, and these points will be used for the placement. So once they are selected, I can simply pin them, trees, okay. Go into our Revit file, and at this point, we are going to use a specific type of family that we haven't used so far, which is 1 point. So normal, let's say, Revit families, not adaptive components, usual Revit families, nothing more than that. We can see in our Revit file, in our dropdown, we have this planting RPC tree. Okay, so we're going to use this family and place our trees on those points. So no computational extreme workflows are needed. We used to do this a lot with Dynamo in the past, but with few clicks, you can achieve the same result. Now, interestingly, the trees are placed to the right level. If you have these points, far from the level, will show an elevation, and also you can bring along the properties. the properties, and so on. So, but now let's go and update these trees. And remember, this is exactly the same as the adaptive components. The mark is our parameter that will keep linked the families, our elements, to the to the Rhino points or lines. So we go back into our Rhino file. We select some of the points. We move them. We can play with these. Maybe this is nice if, I don't know, if you have like a Grasshopper script to move this, to create something interesting, or you simply want to move this tree somewhere else. We go back to the RF tool, we select the trees, and then we can just update them, calling them trees 2. Now let's go into Revit with the usual Ursa. I'm going to search for the tree, and I'm just going to update them. So I don't have to delete them, I can just update them. Now, when I select the tree, when I select the trees, I can see that they are placed in the closest level, to the closest existing level based on the specific point. And now we also have an elevation from that level. So basically, it behaves exactly, it is a native Revit element, so it behaves perfectly. And at this point, I can do many more things. I can even go back just to show how easy it is to go back to our previous layout. No, I made a mistake because I didn't select the trees, but I'm placing a baluster now. Let's go back and select the trees. I just undo, and as we said at the beginning, all your let's say modifications to the Revit file are listed in here, and you will have the Revit, Ursa, or BEAM, or any other tool that we have used in BEAM, with BEAM in this workflow. So let's go to Ursa, and we're going to use trees, and I'm going to select the right tree. Okay, and I'm updating them. So let's also see a little bit of error handling. If we select a wrong type, let's see what happens. Now I have trees, so we know that we must use 1 point elements, but I'm going to select 6. So what happens is we're going to just get a warning error saying Ursa uses only points, lines, and polylines to place elements. Although the types are excluded, but and we know that we have selected a wrong type of geometry right now. So we have excluded 31 elements. So you get always an error. It never, I mean, we made it, we try to put our effort to never crash Revit, and that's really important for us. We don't want you to waste your work to have Revit crashing or Rhino crashing. So if that happens, once you're using BEAM in your day-by-day work, please let us know, because we really hate crashing Revit or Rhino. So at this point, we can go ahead with our workflows, and we can look at Ray. Ray, we had a little bit of, we tried a little bit Ray already, but we're going to see a little more in detail about this, the Ray workflow. I don't know if you have any questions so far, or if you want to give me an update regarding the time. We have still
1 hour, Mauro. No, maybe less.
Okay.
50 minutes.
Okay.
40 minutes.
Okay.
Yeah.
Just keep me informed. Okay, so let's go ahead with Ray. So as I said at the beginning, we have different options to transfer geometry and data from Revit to Rhino. Let's start from the first one, edges. But for to using this tool, let's use, I think all of you have in your Revit, the sample architecture project. If you don't, please let us know and we'll place it into the data set. Do you guys have this sample architectural project? The usual, you know, the classic Revit house. Maybe you do, but in any case, if you don't, let us know and we'll place in there. So in this classic Revit piece, we're going to use our Ray tool to export some edges. So I can use the first option, select some edges, model something on top of that, and then bring it down back. But before moving to this first workflow, let's talk a little bit more about Ray. You might have, it depends if you have Rhino 6 or Rhino 7, the Ray export is slightly different. So in Rhino 6, we used to export, when it comes to solid elements, we used to export DWG files, and then, you know, using this and underlying technology for our export. At the moment, with Rhino 7, we use the Rhino Inside technology to export the geometry and to create actual 3DM files, which allow us to export much nicer geometry generally, and also to assign better materials with the textures and everything. So if you see that something is different today from what I'm doing, you might be using Rhino 6. So if you upgrade to Rhino 7, the experience with Ray is slightly, or I think a lot nicer, to be honest. Still, we have some more workflows that we can do, even if you have Rhino 6. I don't know, Mika, do you want to add anything on this?
Yeah, all the workflows are the same, other than solid elements and the materials. They are different, as you said,
Yeah.
Mauro. So yeah, it really depends. Basically, the idea is that we can launch Rhino inside Revit ourselves, and so use the full range of commands that were not available before. So that's pretty much why it's so different. So be aware that the version you have will matter in this case. Also, if you have Rhino inside Revit installed, there might be some, let's say, conflict, because Rhino inside Revit and BEAM both use Rhino inside technology. So, but only one Rhino can run inside your Revit application, only one. So what we did by talking with Mikael and discussing, we give the ball to Rhino inside Revit to launch Rhino. So you might need to first activate Rhino inside Revit, and then Ray will be able to use that same Rhino session to perform its operation. So if you have Rhino inside Revit installed and you see some weird behavior, let us know. We can explain how to do it. It's pretty simple, but it can be maybe confusing. Okay, so just let us know.
Perfect. Thank you, Mikael. So at this point, we can start with different workflows. So as I said, let's start with the extracting the edges from the Rhino geometry, from the Revit geometry, and sending it to Rhino, and use this as a base for our modeling. So if I select the edges using internal origin, we can also use shadow origin. It depends of the arrangement of your file. I'm going to select, and I can go and select few edges. Just finish. We click on the usual top left bar. We assign a name, and easily using Ray. Well, I can just delete this. Using Ray, we can see that we have geometry. This file is about geometry. We beam it, and in much less than a second, we have our lines ready for our modeling. So at this point, I can just using this as a base. Sorry, as I said, also yes, I'm not the best Rhino designer, but let's see what I can do with this, so I can just select something and create a shape, assign a material. Maybe I can use this as a, well, let's also take into Revit the materials from our Rhino, from our Revit file, so it's more complete. Parameters, materials, and I want to use some of the materials that are in these files. If I click, so I don't know if I mentioned this today, if we click without specifying any name in here, we'll just generate a new code for us. So in Ray, then I have this code, and we are talking about now Revit properties, and I have all the materials. So I want to use some, I don't want to think about creating new materials in Rhino. I want to get some materials from Revit. I'm going to select all the materials. And let's finish with our modeling. I can offset this surface. It's a bit thick. Let's do it 50. And now from our drop-down menu, I can choose between all the materials that I've imported from Revit. Silver aluminum, maybe. Let's go to a rendering mode. We can see also we have our reflection and everything. So at this point, the only thing that I have to do is to create a family, called like maybe just a new ceiling or beam ceiling. Sorry, for my phone there was a call. And we can specify the category for the ceiling, family beam ceiling. I can use a subcategory if I need. Everything else I can just leave by default, but as you've seen today, we can use more bespoke parameters, proper custom parameter for our family. But we are ready to go. So I'm going to use F. I don't even need, at this point I have only one element. Beam it and call it ceiling version 1. When we go back into Revit, we can use beam to place our new ceiling into our Revit file. So I'm using 2022. Let's see, fingers crossed. But everything went pretty well. We have a new ceiling with a design that is not super straightforward in Revit, as you know. It is placing in here. I can go back to Rhino and keep doing stuff with this. Okay, I can just go in here and do some of other things. This is what we love about Rhino, no? We have more freedom. Okay, just going to select our object, and in this case, we're going to call this ceiling V2. Okay, let's go back into Revit. In BIM, we have our V2 that we imported. Maybe if it's not too crazy, we'll go okay. We'll be okay. Okay, and this is fine. So we can keep going back and forth with just the use of a few clicks. There is not too much stress on doing this workflow. As I said, this is a proper category ceiling. It will be scheduled as ceiling. If you are exporting to IFC from Revit, it will be assigned to an IFC ceiling type. So, you know, apart from like few limits that we have on the modification of the edges on when it comes to this kind of imported objects, but for everything else, especially for architectural stages, I think it's good enough. That's what we have seen in different projects in different offices. And at this point, then we can just go ahead with our workflows. As I mentioned, something that sometimes some problems that we have when we work in two platforms is like that we don't have the same alignments, and that's why we thought it was nice to include a tool of grids and curves, for example, to bring the curves from to bring these special elements from Revit to Rhino. So let's see how it works. I'm just going to select all the lines that I have in my view. We filter already. You don't need to think about it because we filter already out the solid elements. We click on finish. We say these are the grids, and we go ahead and use Ray to import the grids inside our file. And when we select the grids, we can see that the grids are imported to a specific layer, and this is another thing that might make your life easier. Is inside a Revit with a name of the Revit file, grids as the name of the layer, and then also I have brought in some room separation lines. So let's make the grids red, and we at this point we are sure we have a good setup, and we know that whoever is working on the Rhino file is working on with the correct coordinates and correct alignments. So it's good for a peace of mind. Let's go back into our Revit file. Let's see how the other workflows that we propose, and let's go to the 3D view. And this is where we see the power of the new workflow with Rhino 7, because when we select an object with textures, let's see also this chair that usually has a nice texture assigned. If we bring this solid geometry into Revit, into Rhino with Rhino 7, so using the Rhino Insight technology, we can benefit from the new assignment of the materials, the proper assignment of the materials and the textures. So solids. Okay, let's go back into Rhino, and we go to Ray. Again, it's good to know that we are talking about solid geometry in general, and where we import. Now we can see that we were able to import the geometry with all the material textures. Also, if we zoom in, we can see the detail of the, we can also see nicely the texture of the material applied. And at this point, it's worth mentioning, I'm not really aware if Enscape runs also into Rhino. I think so, or any other real-time rendering engine. But if you're using Twinmotion or anything like this, it will pick up these materials, so you can go ahead also and do your file. Now, I think I'm working with a specific units. I might need to check something in my file, but the point is we were able to import. Let's also look at the chairs. We were able to import the elements with all the textures applied. I need to check. Let's do a new file in meters and import again, just to clarify a little bit. Yeah, and now everything is clear. So you can see the level of the texture applied to the objects. From this point, you can go ahead with the V-Ray or any other tool if it's needed for your Rhino designer, and go ahead with the rendering. And I think we are getting to almost to the, I mean, we don't have that much time, so I think I will go pretty, I need to go to jump on the Grasshopper automation with BEAM. But if you have any question, please stop me. I can see this, Aline, yes, I don't know if that was a response for something that happened before.
Yeah, it was an answer for a question.
Okay, good. Let's look briefly to the Grasshopper, and then we might have some time for Otmane to show a nice workflow with the adaptive components and BEAM general. So in your Revit, in your data set, you can look for these panels and open this file. Yeah, I'm working with the Revit 22 is a bit of a gamble for the workshop, but that's what I have installed in my machine. So
yeah, Autodesk changed the whole unit system in Revit, and it's not the same as it used to be. So be aware of 2022 has some very tricky parts of it. Yeah.
So when we are working with the, so usually we always suggest to use blocks if you have a modular design, but it might happen that, like in this case, you might have a piece of cladding that is very, they might be really different in all its pieces, and you might want, you can still want to assign a specific information for every single element. So the classic workflow for would installing Revit 21 be better for BEAM? Well, at the moment, Jessica, I will say yes. I think it's just more reliable for what we have seen so far. Revit 2021. The thing is, usually Revit, when Revit goes to the market, the first few releases are a bit unstable, and then there are the hot fixes, and they'll fix some bugs. We also have reported this, which is not like really a bug, but it's something that is not really working 100% for us for the geometry. So they might include this fix on the next release. So at the moment, to respond to your question, I think for BEAM, it's more reliable using Revit 2021.
This applies to any app that really imports content. Also, I want to make a comment here because I'm watching the log, and sorry if I take the chance to talk to Stephanie and any other that is having problem. If you're using Rhino 6 and Ray is failing to import, it means that in your current install of Rhino 6, you never imported a DWG. So you have to, it's a bug in Rhino 6. You have to go to File, Import any DWG you want, and then Ray will start working. Okay, so the message also says that when it fails. So if you try that, you should be good to go.
Yep. So yes, just to make it clear, Rhino 6 we had this little issue. Just import a DWG and then import again, it will be fine. So let's try to finish this workflow with Grasshopper. As I said, if you have a specific design and all the pieces are different, you're not, of course, you're not going to use blocks because it wouldn't make any sense to make a unique block for every of the single pieces, but you can keep the geometry as it is. The only thing is, it's very annoying if you have a complex cladding to assign a family one by one, right? And that's why we thought that then an automation with Grasshopper was really needed at this point. So if you open Grasshopper, in the dataset files, you will find a file called panels. Okay, and inside the file you will find few example of Grasshopper workflows. I already, okay, let me stop this and let's clean up all the geometry, because if your Grasshopper is set on automatic, it will just assign everything straight away. purge the families, and that's it. So a few important notes about the Grasshopper workflow with the Revit, with the BEAM components. You will find our components in here under the MKS tab. All the components are listed here with some specific prefix, and they are used mostly to automate the assignment of the properties to the object, but they can also be used to retrieve the information of the Rhino component or Rhino object that you have in your Rhino document. Okay, for example, if I go and select this family node and I refresh, it will list, at the moment I don't have families in this model, but it will list all the families that I have in the documents and so on. But let's go ahead with the assignment of the properties to the Rhino components. So first of all, we can either use Rhino geometry by selecting and referencing that geometry, or we can use geometry created inside Grasshopper. In this case, for this example, we're going to use this existing geometry. So now I'm just going to disable these nodes, otherwise they start instantly. And what I want to do, so as I said, we want to create a single family for all of these objects. Now, how I'm going to do this?
Yeah, I'm replying, Mauro. Keep going.
Sorry. So what I'm going to do now is to create a single family for every single object. So this is more like a workflow, it's more like a visual scripting workflow. What I'm doing is collecting all these, calculating the length of the list all the components that I've selected, all the geometry that I've selected, using the series component to to create a series from 0 to whatever is the total number of the objects, and then concatenating at the end a prefix that I want with a separator. I can even go ahead and add in a new more strings, and then we can change this. Today we have panels. We had elements. We can change to panels. So panel plus separator plus a single number. So at the end, I'm sure that I'm going to get a single name for each panel. And this is what we want. So we are able to recognize this later on in Revit or in IFC. So now with this component, assign object parameters, we are going to create the families. We are not going to assign custom properties. So this node is specific to create BEAM families into our Revit, our Rhino file. So if I enable this, so no, let's see before the input, so otherwise it starts. As a subcategory, I'm using this cladding. As a material, I'm using aluminum. And also, we recently we are giving you the option to create your sub-layer system when you are assigning when you are creating this geometry, or amending or changing the properties to this geometry. And let's say the syntax to do this is to don't know how to remove that, is to 1 second, is to use the top layer that you want to use, so a name for the top layer that you want to use, double colon, and then the name of the sub layer. Something happened to my, okay. And that's it. Now I can enable, and as you can see, so in a real time, we can see that we are already applying all the parameters to every single element. And if I change any of these,
because the file doesn't have any material, Mauro.
Ah, right. Yes, I thought I was on another file, but yes, but you can see that I'm creating all the, yeah, let's switch maybe this one to be on a glass type. Yeah. So, and so you can, as you can see, I'm changing the material in real time. I just need to type the name of the Rhino material that I have in my Rhino document. So that's super fast to super fast to do in this case. But at this point, you might want. So we have our nice families with the subcategory, the material, a data field that we can use later on in Dynamo if we want, and so on. But at this point, it's also worth mentioning, once we have applied all the families, we can see them listed here clearly in our queue query tool that you can also then export into Excel, as Mikael shown at the beginning on the first 2 hours, and you know, you can extract these schedules directly from Rhino. So now going ahead, let's also apply custom properties, custom family parameters properties to the families, and this is done with another component that we have, which is assign family parameters, AF. Now, when I enable this, we can see that straight away we have all the other properties assigned to the objects, and at the same time, when I open the queue tool, I can see all of them listed here, ready to also. I can also try to use area to extract the area for all the elements, and they are ready to be scheduled. They are ready to be exported to Excel if you need. Also changing the units if you need, and so on. I don't want to go. I think we are getting a little bit late, and I really don't want to go too much into detail about this workflow. But you have this Grasshopper file, so you can experiment as much as you want. But basically, what we're doing is just to taking the families, calculating. I mean, getting the count of all the families that we have in our Rhino file after we have assigned with our node, with our component. And then we are just using doing a little bit of a list, let's say arrangement in here, just to make sure that we have. Also, let's change the category. As you can see, the inputs for these components are category, the parameters, and the values. And obviously the family name. So the family, we can see the list that we are feeding into this component. The first is the families, the family names, and we have, and they are grafted in this from this component. So we are using this tree, graph tree from these family names. They were like a flattened list. We graphed the tree, and that will make sure that let's say the lacing or the assignment of the properties is correct. Then we have the parameters that we want to assign. So this is the name of the parameter, and these are all is a graphed list of values for each element. So now, if you look at this, we can see that we have all of these attributes applied to our families. So again, if this is not clear right now, you can look at the example. I'm going to change this to curtain panel, and you can see how fast it is to change also the category here in our case. I think I'm just going to go super fast now, change the material, import into Revit, and then we move quickly to IFC. Let's use this as steel, maybe. I mean, it's not great, but just for the proof of concept, we're going to export this. So let's select the element. We have all the parameters assigned. We are happy with the curtain panels category. I'm just going to select all of the objects. I could have used F, but I have also just these components, so I can just beam them. Panels. Okay. Almost done. Okay, 2 seconds for the export. Now I can go into our Revit demo file that you also have. And using BEAM, the BEAM, the BEAM blue button. And in this specific case, we're not going to use a lot of families because we don't want to, let's say, mess up too much our project browser and creating, in this case, 250 families. Because that's not what we want, but we want to, so this is something that we would like to avoid, but we want to still schedule all the families and do the material takeoff and extract all the properties and being able then to export to IFC or do whatever we need to do with a proper, let's say, BIM element. So I'm going to select system families. I have my BIM filing here, and I'm just going to BIM this one again. And you can see that the elements are already populated, being populated and created into our file. And briefly, we're going to see that when I select the elements, all the properties are assigned as planned. I could have used a nicer material, but you can do better than this for sure. Okay, so 206 elements imported. When I select them, I can see that they are curtain panels, curtain panel category,